Android-controlled solar-based grass cutter robot. Abstract manual grass cutting requires manpower, time, and it may create non-uniform structure of grass height. Hence, to avoid all these issues, it is essential to create a system which can cut the grass without any human involvement. This research implements the grass cutting robot which has battery which can be charged by solar energy. This robot can be operated using Android phone. This system can be created with minimum cost as compared to other existing systems. This is rugged, durable, and maintenance-free. This system is pollution-free due to the use of solar energy to charge the battery. Keywords: Android, Bluetooth, grass cutter, solar energy. Introduction. The automation is useful at various stages of human life. The beautiful evenly cut grass increases the beauteousness of any hotel, house, park, meeting hall, etc. Hence, uniform grass cutting is important to maintain the prestige of any house or hotel. The manual grass cutting is possible using human being, but it usually consumes time and energy of human being. Also, the manual grass cutting is inefficient and many times results in non-uniform structure of grass. Hence, to avoid all these issues, it is better to use automated grass cutting robot machine which can be operated through Android phone. This research implements the Android-operated grass cutting robot. This system establishes connection with Android phone using Bluetooth. This robot's motion includes following motions: forward, backward, left turn, right turn, and grass cutter on/off. All these motions are controlled by Android application. This robot is operated by using 1 2V 7.5 Ah battery. To charge this battery, solar panel is connected above the battery. Many researchers have proposed a similar design of solar-based grass cutting robot. Ferris-B Ismail ETAL1 implemented a design in which the blades of cutter are placed at the middle of 4 wheels of robot. This will create disturbance during the grass cutting process. If the size of grass is larger, this will stop the wheel and hence this system cannot be used in an efficient manner. Binsi Abraham ETAL2 and Malikarjun Mutta ETAL3 proposed a similar system of grass cutting robot. But this system cannot control by Android smartphone. It has ultrasonic sensor which can detect the obstacle. This system automatically changes its path if the sensor senses any obstacle. Also, this system does not contain 4 wheels. Hence sometimes it creates a problem of balancing in real-time working scenario. Rishabhai Gupta ETAL4 published a survey paper on solar-based grass cutting robot. They had explained the various similar systems and their pros, and Cons Sagar V Palv ETAL5 implemented a similar system, but this paper failed to show the actual model of the system. 2 Material and methods. A. Material. This system uses following material and components. I. Arduino with Atmega 328P microcontroller. Arduino is an open-source embedded system platform. This research uses Arduino platform with Atmega 328P microcontroller. This microcontroller has 28 pins and it is cheaper and efficient as compared to other microcontrollers. Any new C++ language code can be first tested in Arduino 1.6.7 Windows software. After verifying this code, it can be loaded into the Arduino platform using simple USB cable connected between PC and Arduino kit. The figure 1 below shows the Arduino IDE kit along with Atmega 328P microcontroller. 2. LCD display. This research uses 16:2 LCD, liquid crystal display, screen to display the direction of movement of this system. It also shows the on and off status of grass cutter. This is a preferable module over 7-segment and multi-segment LED modules. This is because it is economical and it can show any special and custom character, animations, and so on. This module can show 16 characters on each line and it has 2 such lines. Each character is on this LCD module is displayed in 5*7 pixel matrix. This LCD consists of command register to store the commands provided to this module. The data register in LCD module is used to store the data displayed on LCD display. Figure 2 below shows the 16*2 LCD module. 3. Bluetooth module. This research uses an Arduino HC06 Bluetooth module to transfer the commands from Android smartphone to the system. This HC06 Bluetooth module is mounted on the system along with some relays. Initially, user connects its smartphone with this module. After a successful connection, user can provide the desired direction change command to the system from maximum 10-meter distance. Also, user can switch on and off the grass cutter through its mobile using the Android application. HC06 Bluetooth module is mainly used for short-range wireless connectivity. This is economical and durable module as compared to other existing Bluetooth modules. Figure 3 below shows the HC06 Bluetooth module. 4. DC motor. This system uses 4 DC motors of 1 2V rating to which 4 wheels are connected. This motor converts DC electrical input into mechanical energy by rotational motion of shaft. This motor is cheaper and requires less electrical voltage for its operation as compared to other similar motors. The figure 4 below shows the DC motor. V. Motor driver IC. The DC motor in this system is connected with analog output pin of Atmega 328P microcontroller. But this microcontroller can produce maximum 5V of DC output voltage. The DC motor connected with this system requires 1 2V DC input voltage to operate. Hence L293D motor driver IC is connected between microcontroller output pin and DC motor input. This IC acts as a current amplifier. It takes low current signal from microcontroller and after amplification provides high current signal to DC motor. This high current signal is useful to drive the DC motor. L293D consists of 2 inbuilt H-bridge driver circuits. Simultaneous operation of 2 DC motors is possible in common mode of this IC. Input logic at pins 2 and 7 and 10 and 15 controls the operation of 2 motors. To stop the first motor, input logic 00 is used. Logic 11 is used to stop the other motor. Logic 0, 1 and 10 will the motor clockwise and anti-clockwise directions, respectively. Pin 1 and 9 are enable pins for 2 connected motors. To start this motors, the enable pin of this motor must be high. The figure 5 below shows the motor driver IC L239D. 7. Solar panel. This system uses 1 2V, 10-watt solar panel. It has aluminum frame and its surface is made up with tempered glass material. This panel consists of monocrystalline silicon. This panel is compact, lightweight and economical as compared to other existing panels of similar rating. Figure 6 below shows the solar panel. B methods. This research uses DC 1 2V 7.5 Ah battery supply to operate whole system. This battery is connected with solar panel. Hence solar energy is used to charge this battery. This system has 4 DC motors to which 4 wheels are connected and the blades for grass cutting are connected at the front side of this system. To operate this system, the connection must be established between the system and Android smartphone. Both these are connected using Bluetooth. After the successful connection, the user can operate the system using Android application installed on smartphone. User can switch on and off the grass cutter. Also, he can move this grass cutter in vertical and horizontal direction. The figure 7 below shows the complete system. 3. Proposed framework. The figure 8 below shows the block diagram of proposed framework. As shown in figure 8 above, solar panel is connected to battery. Battery provides 12 VDC supply to the system, which can be minimized to 5 VDC voltage using voltage regulator. The Arduino is operated with 5 VDC voltage. The LCD module, Bluetooth module, DC motors, buzzer are connected with output pins of 8 and the 328P microcontroller. As shown in figure 9 above, initially the 12V battery supply needed to start. This supply will be converted into 5 VDC supply using voltage regulator. This 5V supply will be provided to microcontroller. The Bluetooth module needed to be started and connected to the Android smartphone. Once the connection is established between the smartphone and the system, user can move the system in vertical and horizontal direction using Android application in smartphone. User will start the grass cutter to cut the grass of desired location. After completing grass cutting task, user will switch off the grass cutter using Android smartphone. Then the main system can be switched off by disconnecting the 12V battery supply to the system. 4 pros, cons and applications. Pros. A. Portable structure with compact size. B. Simple operation. C. Less cost. V. Conclusion. This research shows the implementation of smartphone-operated grass cutter. This grass cutter can be operated using Android smartphone within a 10-meter range. The user can perform horizontal and vertical movement of grass cutter using Android application in smartphone. This system uses 12V 7.5 all-lead-acid battery. This battery can be charged by solar energy. To charge this battery, the 12V 10WATT solar panel is connected with this system. This system is cheaper, rugged, and durable. With the use of this system, human efforts for grass cutting are highly minimized. Also, manual grass cutting can create non-uniform grass size. But with the use of this system, the grass cutting is uniform, and one can use this system to cut the grass of any playground. 6. Funding. This research is self-funded. The author of this paper invested the complete amount to create this system. 7. Conflict of interest. All the authors of this publication declare that they have no any conflict of interest for publication of this research. 8. Acknowledgement. Authors acknowledge the guidance provided by Professor Priti Rajput to complete this research. Also, head of ENTC Department of DY Patil College of Engineering, MB Tailajayanpan motivated us to complete this research. 9. Declaration. This research does not perform experiment on any living thing such as human participant or animals.